Okay, thank you very much for the kind introduction. My name is Younsun Kim from Samsung. It's kind of interesting to be the only person attending here face-to-face in terms of presentation. So my presentation today will be the 3GPP RAN1 status and overview. What Wanshi has already discussed kind of on a high level, I will go in a step further and discuss what's happening in RAN1. Okay, so before we discuss what's happening in RAN1, I just want to share with everyone what is RAN1. Okay, RAN1 is the working group in 3GPP that is in charge of the physical layer design of the 3GPP specifications. So we're in charge of the physical channel, modulation, physical layer multiplexing, channel coding, error detection, any physical layer procedures and definition measurements and their provision by physical layer to the upper layers. It is also the largest working group in 3GPP right now. About somewhere between 600 to 1,000 delegates participate in RAN1. And it's now becoming more and more difficult to find a hotel big enough to host these meetings. Okay. So 5G Advanced Release 18, I think already Wanshi and Punit and Peter have summarized the significance of 5G Advanced quite well. From my perspective, it's three things: the enhanced performance and capability of the existing features that we have in 5G, better support for new applications, IoT or side link or satellite communications, these type of new applications that we can realize using the 5G specifications. And next is the bridge to 6G. Now, 5G Advanced started with Release 18, and Release 18 from RAN1 perspective, I've kind of summarized in these 4 bullets. There were 14 work items, which means actual specification support features, and 8 study items, which is basically analytic or simulation-based study into new features done over a period of 18 months. During these 18 months, RAN1 was able to generate 5 gigabytes of email. So email, just email is 5 gigabytes. So it's a lot of emails going back and forth. And we had over 20,000 emails and involved over 600 technical experts for each meeting, and more than 10,000 technical contributions per year. So there was an enormous effort gone into this 5G Advanced Release 18 across the entire industry. There were 8 RAN1 meetings, with 3 of them being electronic and 5 of them face-to-face. Now, in terms of schedule, RAN1 started the Release 18 discussions in Q2 of 2022, and we were able to complete our work in Q3 of 2023, last August, about 3 months ago. And as you can see from the schedule for RAN1 and RAN2, 3, and 4, it's a bit unmatched. RAN1 starts 3 months earlier and completes the work 3 months earlier as well. Now, the reason for this is many of the outcomes in RAN1, they impact the work on the other working groups such as RAN2 and RAN4. So it's better that we finish the discussions first and then allow more time for the other working groups to take care of the impacts coming in from RAN1. And this is the entire work scope that we handled in Release 18. We have MIMO, AI/ML, evolution of duplex, side link, positioning, RedCap, network energy savings, uplink coverage enhancement, network control repeater, dynamic spectrum sharing, low power US, CA enhancements for XR, which is RAN2 LED, mobility enhancement, NTN evolution, which is basically satellite communication over satellites, also led by RAN2, UAV, less than 5 megahertz dedicated spectrum. So it was a big project. There was a lot of things being discussed within this Release 18 context. And in the end, I'm kind of happy to say that for the most part of what we were tasked to do in Release 18, it was completed on time. So in the next couple of slides, I'll go into what we did in Release 18 with a little bit more detail. Now, the first topic is AI/ML for NR interface. So this is the first time that RAN1 has taken a look at how to use AI/ML for NR interface from the specification point of view. So AI/ML, even in conventional communication systems, are widely being used. However, those are being used without any specification support for them. So it's mostly a implementation-based solutions that are currently in the field. Now, what we were looking into in Release 18 is, can we augment our own air interface specifications to allow and improve the performance of AI/ML? Is this something possible? Can we tweak somehow the 5G specifications so that AI/ML can do a bit better? Now, we selected 3 target use cases for this purpose, and these 3 target cases, they were selected because there is a reason. Now, although these 3 use cases are currently supported in the specification, there is a hurdle. It either involves a lot of computation complexity from either the G-node B or the terminal, or it has some limitations on where it can be applied. For example, CSI feedback. Now, CSI feedback has been a topic of many 5G releases. However, it still remains the fact that to get a very accurate channel status information for MIMO operation, you need a lot of overhead, and the computation burden on the terminal is huge. So the question we are now asking is, can we use AI/ML to perhaps reduce the overhead or reduce the computation complexity? Beam management, the same thing. In 5G, we introduced this concept of multi-beam operation to facilitate the millimeter wave spectrum cellular operations. Now, what multi-beam operations entail is that the terminal has to measure a large set of beams. Can we use AI/ML to maybe reduce that measurement burden on the terminal? And then there's positioning. Now, positioning, as well as CSI and beam management, is something that's supported in 5G. However, the limitation of the current cellular positioning is that as soon as you lose line of sight, your positioning accuracy drops. So if there's no line of sight with the base station, your positioning accuracy drops miserably. And the question here would be, can AI/ML help to address this? Now, in the Release 18 study item, being the first time that RAN1 looked into AI/ML for NR interface, we focused on the overall AI/ML framework investigation, the model generation, inference, operation, collaboration between the terminal and the base station, lifecycle management, data set management, and so on and so forth. We also did an extensive evaluation campaign on trying to find out what are the benefits of AI/ML when it's coupled with NR interface. We also did a preliminary assessment of the potential specification impact. So what kind of specification change to the 5G specification would be needed? Now, this work was supposed to be completed in Q3. However, RAN has decided to shift the target date by a quarter. So now the new target date is Q4 of 2023. Now, the reason for this is AI/ML being a new thing in RAN1, we felt it would be better to ensure a proper study with more time. And as the RAN Chair 1, she mentioned, we are now under discussion for potential normative work in release 19. And then NR-MIMO evolution for downlink and uplink. This is another big project that RAN1 did. MIMO has been one of the most successful technologies that 5G has. It has been part of the 5G discussions since release 15. So every release had some flavor of MIMO as part of the discussions. In release 18, we focused on 4 areas: multi-TRP enhancement, which is basically terminal getting transmission from multiple, perhaps, base stations or multiple antenna points, reference signal enhancement. So you need DMRS to demodulate, you need SRS for the G-Node B to figure out the channel status on the uplink or even the downlink, and then with it enhancements to have more DMRS ports and better SRS interference randomization, with it CSI enhancements, and we also did major enhancements in terms of the uplink enhancement. So this is to facilitate the case where the UE has multiple panels in its hardware, and the UE utilizes these multiple panels to do simultaneous transmissions to multiple base stations. And then ATX uplink transmission as well. And this is another topic that will find its way back to release 19, where we further have normative work to take the specification one step further. And then network energy savings. Now this item is new for RAN1. And the motivation comes, of course, from the operators. Right now, the energy cost takes up to 40% of an operator's OPEX. And for that 40% take on the operator's OPEX, about 87% is taken up by the base station, basically the RF circuitry which generates the signal that's being sent to the terminal. So the question for us and the task that we were given to RAN1 was, can we do something about this? Can we reduce the energy consumption at the base station? And during the course of release 18, we looked into, we first developed the network power consumption model, and then we did an extensive evaluation on different kind of network energy saving techniques in the spatial domain, which is basically in the antenna domain, in the power domain, which is basically trying to lower the power level, in the time domain, in the frequency domain, a lot of different areas. In the end, given the limited time that we had in release 18 and the priorities and the benefits that we saw, we decided to have support for spatial and power domain techniques and also enhancements on cell DTX and TRX. And again, this is another item that I'm pretty sure that there will be additional enhancements in release 19. And then duplex. So evolution of duplex is another new thing that RAN1 has looked into in release 18. Now, one thing we kind of observed, and I'm pretty sure everyone has also experienced to some extent, is as we go into 5G, there has been a lot of concerns on coverage. And one of the reasons that the coverage is kind of limited is due to TDD. In contrary to FDD, where the terminal gets to transmit on all time resources, in TDD, the terminal gets to transmit only in a specific, a fraction of the time resource. Now, because there is smaller time resource, that inevitably brings less energy at the base station receiver side, and as a result, the coverage is limited. Now, what RAN1 looked into over the last about 18 months was, can we tweak TDD to realize something like what you see on the right side of the slide. We call this sub-band full duplex. So in a TDD band, we create a tunnel just for the uplink. And this, from the base station point of view, this operates as if it's in a full duplex mode of transmission, but with orthogonal frequency resources. And then low power wake-up signal. So again, for 5G, because the bandwidth has become large, the UE power consumption is getting more and more serious. So this Release 18 study item focused on whether we can introduce a new signal, new waveform, that has a smaller bandwidth, that requires a smaller power consumption at the receiver. And this will be used in conjunction with the existing 5G waveform to help with the terminal side battery saving. And this is another item that the discussions are underway for potential normative work in Release 19. And then extended reality, I guess this extended reality, or XR, has been a hot discussion point inside and outside of 3GPP. In 3GPP, this is led by a RAN2. But anyway, from RAN1 perspective, what we try to look into this is how to facilitate this combination of high data rate and low latency. So according to some of the studies that 3GPP has done, some of the member companies actually, acceptable XR experience requires a frame rate of at least 60 FPS and 2K resolution per eye. And immersive XR experience requires a frame rate of even higher and resolution of much, much higher than 2K, actually up to 8K. Now, what this means in terms of air interface is the data rate has to be guaranteed to a level of up to 100 megabps, with latencies going down as far as below 10 milliseconds. So how does RAN1 kind of change our specification to better facilitate this? This was the focus of the work in Release 18. And then NTN, non-terrestrial network. So this is not a network that's on the ground, but something on the air. It includes, I guess, planes as well, but mostly the focus was satellites. So this is one of the big changes that we have in 5G compared to LTE. I mean, LTE, of course, LTE right now also supports NTN, but for eMTC and NB-IoT only. So what we did in Release 18 was we introduced specification support to take care of the critical features to address frequency and time synchronization issues relevant for satellite communications. So if you have a GEO, the time delay between the terminal and the ground will be huge. If you have a LEO, low Earth orbiting satellite, then since the LEO satellite is rotating the Earth in a very, very high speed, you have a huge Doppler shift that varies with time. So the air interface needs to somehow compensate for this. So that was the focus in Release 18 and in Release 17 and Release 18. We took that a step further, and for NL, we had some coverage enhancement, network verified UE location, and for LTE, eMTC, and NB-IoT, we had disabling of HARC feedback and improved GNS operations. Again, this is another topic that we find further enhancements will be happening in Release 19. So this, I think, is the last slide I have for the introduction of the topics that RAN1 is discussing. This is not an exhaustive list. This, I think, only covers a fraction of what RAN1 has done. But I felt that this was kind of more representative things that we have been doing in the context of 5G Advanced. And that concludes my presentation. Thank you very much.
you.